Hello everyone, and thank you for coming to this presentation. So today I'll be talking about a study I did with some colleagues at Baylor about how studying developmental growth with multi-level models for linear and categorical change. And so to give a kind of a brief outline, so I'm just going to give a very brief introduction to the purpose of this talk. Then I'm going to go into the data we used as a guiding example for the growth modeling and transition modeling we are describing and discussing. And then we'll wrap up with some conclusions about how both these approaches to modeling can be complementary and sometimes give a different view of the data. Okay, so the purpose is we were discussing about how longitudinal methods and modeling are very needed and very prevalent in educational research. And so the kind of need for this is coming from how studying developmental change can occur. And so what developmental change can mean in educational research is highly varied. It could mean how do different types of behaviors occur or change occurrence over time. It could mean how does different social or emotional characteristics and constructs change over time. It could mean how does the kind of ability individuals show in terms of cognitive abilities like math knowledge or different types of traits like that, how do those change over time? And so the purpose of this presentation is to help discuss two different approaches to studying longitudinal change. And so one is using a relatively simple multi-level growth model, and so that is a very common approach. The other is a slightly more advanced using multi-level latent transition analysis. So both of these kind of help us understand data in a slightly different way and have different kind of theoretical underpinnings of how change occurs, which I'll get to in a minute. So to help guide understanding these tunes, we use the National Longitudinal Study for Youth back from '97, and we use their depressive symptoms items. And so we only use the first three waves from 2000 to 2004 in order to help simplify the analysis and help give a nice introduction to how these methods can be applied. And so we wanted to pay special focus to the how family effects might influence individuals, because this is a very rich data set that has a lot of families, multiple youth from the same family in the data set to help investigate these types of matters. And so the items that we focused on are the 5 items that they had publicly available for depression. Was one about basically how nervous they've been, how peaceful or calm they've been, how down, how happy, and how depressed. I'm a big fan of the item G, how depressed you were, because it's very direct. I'm a big fan of direct items, and so we also reverse coded item D and F to help kind of make sure all items had the same directionality of being high is basically indicates more or less depression. Okay, and so again, our purpose is to really try to investigate how does family membership influence change over time and depression. And so we really wanted to focus at this in 2 different ways. Basically, how does overall depression level change versus how does identifying different kinds of change over time occur. And so that is the difference between kind of looking at a continuous process versus looking at a categorical or kind of stage change. Okay, so for the growth modeling, so growth modeling is really the underpinning of trying to understand how does different how does a continuous process or level of depression change over time. So this is really akin to modeling the depression scores as like a total score, which is kind of like just the sum of the indicators. That is a measure of the severity of depression. So really want to try to get at how does this level of depression change over time. So using the growth model, we can basically develop a pretty simple, straightforward three-level model that basically nests time within youth or children, where children are also then nested within family. And so as we go down the hierarchy, we see that family influences child or youth, which influences time. And so differences between time are a measure of how does the depression score basically manifest at each time point. So this allows us a nice kind of hierarchy of where does an influence occur. And so we're going to pay special attention as to basically how does basically the variability in these random effects up here influence the observed direct effects at each time point. And then again, looking at how family random effects also basically trickle down to cause effects at each time point. And so the results are pretty straightforward. The average level of depression, because we centered at age 18, was about 15, and as an individual gets older, the level of depression is expected to increase. And so that is really a measure of basically getting better. We wanted this total score is really a high means that they don't have very much depression versus a low means they have a very low level of depression. And so we want this to actually increase on average. However, once we move to understanding the random effects, we said there's a high variability in the intercept, so where an individual starts, versus how the change occurs. And so both of these are the standard deviations, and this is a measure of the correlation between those random effects. So at the youth or child level, there's not a very strong relationship between where their starting point is versus how their change occurs. However, this changes pretty dramatically once we move to the family or level 3 part of the model, where again there's still a pretty high variability in where families start on average, but there's a very strong relationship. When a correlation is negative 0.65, that's a pretty high evidence that where the individual starts is pretty indicative of how the change is expected to occur. And so what we see, because this is negative, individuals in a family that have a very high starting point or high level of depression actually go down over time, which is not a something we want to see. We would like to see this be pretty basically close to zero as a measure of basically that the family isn't very influential over time. So next, we can look at kind of like some different R-squared like measures. And so basically at the family, as it's probably understood by the correlation being so strong, family actually accounted for almost 20% or 0.19 proportion of the variability in depression scores. However, that is very different in contrast to an individual, where an individual only accounted for between 1 and 2% of the variability in depression scores over time. That's very low compared to family. And so this modeling it as a continuous process gives pretty much a lot of evidence that the family membership is pretty influential in how does depression scores change over time. Next, we're going to move on to the transition modeling, or latent transition modeling specifically, and we're going to look at states of depression. And so we're looking at how does the individual items are basically a measure of which latent class an individual is in. Okay, so what we're going to do is in the latent transition modeling, we're going to focus on just being a two latent class model. So there are two latent classes at each time point. So this is time point 1, time point 2, and time point 3. And so what we're looking at is how does one of two latent classes of individuals change over time. First, it can change over time because where you're at time 1 is going to be indicative of where you are at time 2. Which class you're in at time 2 is indicative of where you are at time 3. However, we also have this family influence. So each family has a different propensity of being in one of those two classes. And that potentially varies across families. And so family can also influence the likelihood of being in a different class. And that likelihood can change over time for families. And so we get this really interesting kind of interaction between how does the family propensity to being in a class influence individual propensity for being in a class, and how that changes over time. So we can really get a measure of basically how does family influence at time 1 influence child propensity at time 2. And we can do that from 2 to 3, 2 to 2, and 3 to 3 as well. And so one of the things we're going to look for in the results is basically how does family, what is basically the influence of family at later time point depression states, and how does previous time point depression states influence current. And so those would be two differences in how does family versus individual affect. Right, so now the two latent classes that we extracted, mostly for simplicity, further studies should be done to kind of dig into how many latent classes there potentially might be needed to express these data. But in this case, we extracted two for didactic reasons, and we basically get this one class where it's pretty like happy and not depressed, and one with the more propensity for depression scores. Right. So then looking at that complex plot again, we're trying to basically understand, hey, at level 1 depression, basically the logistic regression at each of these time points is a pretty similar measure over time, and so that we expect that the child or youth influence will be pretty constant over time. Whereas at level 2, we expect that the changes in family dynamics or family influence to be pretty drastic over time, because this is only about negative 0.1, and over here we get a negative 9.6, and that's a pretty big difference. One of the interesting things also is just how variable the intercept is at time 1. So this basically means that the variability in family propensity for each latent class is varied. And so that also basically stays pretty constant over time because there is a pretty low residual variance. So that means that the variability stays pretty constant at the family level. Even though it changes pretty dramatically, the variability is constant. Okay, so when we get into the kind of R-squared measures of trying to understand how does these components really change over time, we're looking at basically family at time 1, about 10%, versus time 2 on time 3 is only about 3%. So family seems to be less influential over time. The other main takeaways from this is that this C to T minus 1 row, and basically time 1 to time 2 accounts for about 25% of the variability in class membership at time 2, whereas time 2 membership accounts for almost 36 to 37% of the variability in time 3 class membership. Um, Lastly, we have that adding that family level, basically adding that random effect across families for different propensities for being in the different latent classes, accounted about 3% at each time point. So that's a pretty indicative that the family influence is constant over time. Okay, so in conclusion, we basically find that there is, from the growth modeling, that there is pretty strong evidence, or that there is evidence of a strong relationship between age of and the trajectory, and basically how you start with your family and what your depressive severity changes over time. And that's mostly at the family level, but individual or youth level, it's not as significant. But in the transition modeling, we found a lot of evidence that the individual class membership was predictive of future class membership. So this is where we see a kind of a somewhat different view on these data, to where we see that individual place makes a very is very influential at the individual level for the course membership that you're in, but maybe for the fine-grained severity level information, family might be more important, even though we also found evidence that the family effect in the transition modeling was pretty constant. So this is where we could dive into these types of models more by adding different covariates for the individual versus the family to try to dig into where these effects might be taking place and what family characteristics might account for these. So thank you for your time.